we are going to actually work on figuring density. When somebody tells you that they're actually going to measure density, that is an incorrect statement. There is no measuring density. That is a no. Instead, what you need to do is you actually need to measure the mass and the volume of an object to get its density, because there's a formula that you saw in the reading and was mentioned in the videos. The formula for density is density equals mass divided by volume. And I'm not expecting you to memorize this right now, but I do expect that you can use this. This is extremely basic. I wouldn't even call this algebra. So it's pretty basic math. All right. We're going to get some scenarios and some problems that we're going to do over the next few days to practice this, but I just wanted to walk through this today because there's two types of questions that you're going to get. The first one is where you have to use a ruler and you have to figure length times width times height in order to figure volume. And the other one is using a graduated cylinder, and you're using water displacement to figure volume. Okay? There is an accompanying video that talks about how you do it with these two types of measurements with the ruler and the graduated cylinder, so make sure that you're checking out that video. It is a repeat of something we've already watched. Alright, so let's start with a ruler. And let's say that you have any regularly shaped object. Regularly shaped means that you can easily measure the sides of that. You'll have to forgive my awesome cube here. You should know by now that to find the area of a cube, you're going to use the formula, which is length times width times height. And that's going to equal its volume. So, in this case, I have a side that's 4, I have a side that's 1, I have a side that's 2. And I'm going to plug into this formula here. We're going to plug in 4 times 1 times 2. And the answer to that is 8. And the label in this case for volume is cubic centimeters, or cm3. Now, if we were figuring the density of this object, we would also need to figure this object's mass, and we would use a triple beam balance to do that. And let's say when we did that we got the mass of this object, we'll make it easy. Let's say the mass of this object was 2 grams. So now to figure density, we use our formula, and then we plug in the mass and we plug in the volume. The mass was 2 grams divided by 8 cubic centimeters. Now, in this case, to do this in my head here, I'm lying, I'm doing it with a calculator. You're going to get 0.25, and it's grams per cubic centimeter. So again, what we did here is we found the area of this cube by taking length times width times height, and we found the volume to be 8 cubic centimeters. We assumed that the mass was 2 grams. We would have used a triple beam balance to find that. And then we plugged those into our formula, and we did the math to figure out that it was 1/4 gram per cubic centimeter. So sometimes you have an irregularly shaped object. So let's just call that a rock. Okay. There's no way with a ruler that you're going to be able to find length times width times height. So we use a graduated cylinder. You recognize these from class. So what you're going to do is use this graduated cylinder to find the volume of the rock. And you can remember from what we did last week that to find the volume, you're going to put some water into the graduated cylinder, and we're going to measure that. Let's say that this is 10 milliliters right here. And we're going to take that rock, we're going to put it inside the graduated cylinder, and what's going to happen is instead of that rock keeping that water level the same, now that water, let's say, goes up to here. And we have the rock inside of the graduated cylinder. Okay? So we had it at 10 milliliter. Now this is at, let's say, 12 milliliters. So to get the volume, we simply take the 12, we subtract out the 10, and we are left with 2 milliliters. Now to continue and figure the density, we need to know the mass. And so we use a triple beam balance, and let's say when we did that, we found that the mass of this rock that we were looking at here, let's say that it's 0.5 grams. So to figure density, we simply use our formula, density equals mass divided by volume, and we have 0.5 divided by 2. You would think I could make these a little bit easier for us. And again, 0.5 divided by 2 is 0.25. I don't know how I made that work out like that, but I did. And this would be 0.25 grams per milliliter. Now, something to note while we're working here, some of you are going to ask the question, how can I have milliliter and how can I have cubic centimeter? And first of all, let's make note that 1 cubic centimeter is equal to 1 milliliter. They're interchangeable. You could actually put that label for either one. Usually what we say is a cubic centimeter is for solids and a milliliter is for liquids. Let me explain this a little bit better for you. So let's say that we have a cube, and bear with me, we need to try to imagine that these are completely equal sides on here, because it is a cube. So we're saying that each one of these sides is 1 centimeter, which means that it's 1 cubic centimeter total. The reason why 1 cubic centimeter and 1 milliliter are exactly the same is because inside of this 1 cubic centimeter cube, you can fit exactly 1 milliliter of water. Again, in this cube, you could put 1 milliliter of water, so they are equal in their volume, how much space that they take up. So that is an example of how you do these two different types, the regular solid using a ruler, the irregular solid using a graduated cylinder and water displacement. We're going to do several practice problems over the next few days trying to make sure that we can do that. Remember, some key things that we talked about here. One you're never measuring for density. You're always measuring for mass and measuring for volume and then figuring density. And remember that formula for density is density equals mass divided by volume. And then we have those two different ways that we just talked about in 2 different ways to figure volume out.